Assalamualaikum warahmatullahi taala wabarakatuh, and good day everyone. Alright, so in today's asynchronous lecture, we are going to start with a new chapter 5, partial differential equations. If all this while we're talking about ODEs, right? Okay, which is ordinary differential equation. But today in this new chapter 5, we are going to discuss about partial differential equations. So apa beza between partial with the ordinary differential equation? So make sure for today's learning outcome, okay, later on at the end of this video, you are able to differentiate the difference between ordinary differential equation that we have learned before in the previous chapter and this partial differential equation. But I'm sure some of you may get the clue already. Okay, before this we have learned about partial derivative, am I right? Okay, so this chapter actually consists of not too long, I may say, same as like chapter 4. Alright, in this chapter we are going to discuss on on this following subtopics, which are basic concepts of PDEs, wave equation, solution by separating variables, heap equation, and Fourier series solution. Okay, so for your information, in this chapter, I'm going to divide into two parts. Okay, so for today's synchronous lecture, we are going to cover these three things. And in fact, for wave equation ni, I leave it to you as your self-study. Nanti saya akan tunjuk lah. Alright, what you need to do for your self-study, just tengok video sebenarnya. Alright, and this one we will keep it for your part 2. I mean a second series of videos. Alright, so let's begin with the introduction of PDE. In comparison to the ordinary differential equation, PDE is an equation that contains one or more partial derivative. Okay, one or more partial derivative of an unknown function that depends on at least two variable. So that makes the difference between PDE compared to ODE. Before this, ODE, you are given a differential equation. At the end of the day, you are able to find the solution where you just have only one variable, where you have the variable x. We just have y and x. Where maybe sometime you are implicitly express the solution, maksudnya you tak boleh nak express y in terms of fx, you macam mix up cos xy plus with e power of y equals to 5, for example, something like this as your solution. But still we have only one variable, dependent variable. Okay, however, PDE, it has one or more partial derivative. Okay, what does it mean by partial derivative? Okay, we have discussed about partial derivative before this, right, in ordinary differential equation, especially when we want to use the exact equation method, okay, of an unknown function that depends on at least two variables. Okay, at least two variables. Now before this kita hanya ada x and y, okay, where y is x is independent variable, y is the dependent variable of x. Okay, depends on at least two variables. Okay, before this only one variable lah, which is x. Okay, usually one of these deals with time. Okay, that variables that the function depends at least two variables, and one of them usually is the time as variable t, and another one is space. Okay, space ni apa? Itulah x, y, z. Okay, before this we used to use x, right? Okay, the space, the dimension, okay, is either x, y or z. Okay, so maknanya the function in PDE, partial differential equation, it basically biasanya akan depends on time and space, and normally space ni kita guna x lah, very common variable. Okay, so nampak tak bendanya nampak macam makin complex because the function depends on two variable, tapi in real life this is actually normal, maknanya biasa digunakan in real life applications. That's why PDEs are very important in dynamics, elasticity, heat transfer, electromagnetic theory and also quantum mechanics, because biasalah kalau any signals, okay, is always varies between time and the distance kan. Okay, so dari situ kita dah nampak it depends on two variables. They must have a wider range of application. See, okay, dia lagi practical untuk digunakan sebenarnya compared to ODE, sebab ODE hanya rely on one variable, which can so that we should rely on one variables, then it can only model the simplest physical system yang mana hanya ada one dependent variable. But for PDE dia at least ada two, boleh jadi 3, 4, 5, but for our course here we just focus 2 je lah. Alright, okay. So here basic concept of PDEs. Alright, so there are few actually equations of PDEs. Okay, macam yang kita belajar sebelum ni lah, differential equation. We are given to us the differential equation. At the end of the day, what we are going to do, okay, what we have done, we are looking for the solution of the ODEs. Betul, we are finding what is the solution of the ODE, then we are getting y equals to fs using various types of method that we have learned, including Laplace method, the latest method that we have learned kan in chapter 3. So same goes for PDEs. For PDEs maksudnya we are going to find the solution for our partial differential equation, but our solution now is not only y equals to fx, okay, but we are going to have uxt. Kita akan ada dua variable, okay, for our function that we are looking to forward untuk solve nanti. Alright, so make sure all of you now clear what does it mean by PDE and what we are going to do actually. What we are going to do is we are given PDE, we want to find the solution for that PDE, where that PDE now it consists of two dependent variable. Okay, I used to use x lah. Kita ada x, y or z sebenarnya, and also variable t. Okay, so the order of the highest derivative is called the order of the PDE. So kat sini kita ada there are 5 second order, okay, second order PDE. Kalau you tengok ni, the derivative ni is power of 2. Okay, the power of 2 is the highest order dalam equation tu. Okay, so the first equation is what we call sorry is what we call as one-dimensional wave equation. Okay, one-dimensional wave equation. And the second one is the one-dimensional heat equation. Apa beza antara dua ni? Cuba nampak apa tak ada beza tak? Dia tak ada beza pun sebenarnya. Del square u, dt square. Oh, ada beza. Okay, so the difference is that, okay, for wave equation, u del square u over dt square. For heat equation is just du over dt. The right hand side tu sama je. And then we have two-dimensional Laplace equation. Okay, like this. Beza. Okay, and then you have we have also two-dimensional Poisson equation. The difference between Laplace and Poisson equation you see on your right hand side here. For Laplace is equals to 0. For the Poisson equation is equals to fxy. But for our case, I think we'll focus on equation 1 and equation 2 here only. Alright, so now let's move to example 1 untuk you betul-betul fahamkan dulu apa maksud with partial differential equation. And untuk apa ni, macam yang saya cakap tadi, okay, when we are given the partial differential equation, we are going to find the solution. Okay, we are going to find the solution of the partial differential equation, basically uxt lah, equals to what? Okay, but before that, let's have a look at example 1. Show that the following functions are possible solution of this partial differential equation where we have del square u over del x square plus del square u over del y square equals to 0. So kita ada solution kat sini. Maknanya dah ada jawapan sebenarnya. We just have to prove that this jawapan suits the PDEs here. Okay, so untuk A ni kan, we have u equals to x square minus y square. How can we prove that it suits this PDEs? Okay, very simple, because we have here del square u over del x square. So kita cari je lah daripada u ni. Kita cari del u over del x. I don't think I have to explain to you anymore how to find this partial derivative, because in chapter 2 we have discussed about this kan, when we were solving the exact equation method. Okay, so del u over del x means that we differentiate u respect to x. The rest we regard them as the constant. So x square differentiate, we get 2x, y square now become a constant, so 0. Okay, so we have del u del x is equals to 2x. Then from here we get del u square del x, del square u over del x square. So differentiate 2x. Okay, akan dapat apa? Dapat 2. Okay, kat sini kita dapat 2. Alright, let's have a look for del u over del y. Del u over del y ni, okay, x square. Del u del y x square minus y square. Differentiate respect to y, you're going to have negative 2y. And then del square u over del y square of negative 2y, you're going to get negative 2. Nampak? So sekarang ni we have del square u del y square is negative 2. Kan? Kalau masukkan ke sini, del square u over del x square is 2. So it's equals to 2. And del square u over del y square is negative 2. So minus 2. Dapatlah 0. So is it proven? Yes, definitely it is proven. Alright. Then next, let's try for B. Okay, for B pula, u equals to e the power of x cos y. Betul tak? Oops. Okay, kita ada e the power of e the power of x cos y. Okay, so u equals to e the power of x cos y. So let's have a check. Let's check. Del u over del x is going to be equals to e the power of x cos y. Del square u over del x square, again differentiate e the power of x, kita akan dapat e the power of x cos y lagi. So try for del u over del y, differentiate e the power of x cos y ni with respect to y, kita akan dapat negative kan, because differentiate cos we get negative sin y. So saya letak siap-siap negatif kat depan tu. And for del square u del y square of negative e the power of x sin y, we get negative e the power of x cos y. So dari sini del square u over del x square plus with del square u over del y square equals to e the power of x cos y minus with e the power of x cos y juga. So it's gonna be equals to 0. Right? Okay, so we have done for A, for B as well. C, saya bagi kat you all lah. Try show that this is gonna be equals to 0. Okay, so I leave it to you to solve on your own for your 1C. Okay, what using the same method, like equal apa ni, buktikan it will gonna be equals to 0. Alright. Okay, so now next, okay, basic concept of PDEs, okay, fundamental theorem of superposition. Dia punya ni maknanya solution of PDEs adalah U. Kita akan dapat U as our solution. So, kita punya solution tu nanti we will have C1U1 plus C2U2. Kalau compare dengan ODE sebelum ni pun macam ni juga kan. Ingat tak ODE sebelum ni kalau Y double prime tu you convert it into Y double prime plus minus 9 for example equals to 0. So you convert it into auxiliary equation. You have R square minus 9. So you have R equals plus minus 3. So we have Y equals to C1 e to the power of 3 X plus with C2 e to the power of minus 3 X. Kan? Ni maknanya first solution. This is second solution. And this is the general solution. So sama juga dengan PDE, kita ada solution, first solution and the second solution. Okay, so it's mentioned that if U1 and U2 are solutions of homogeneous linear PDE, then U ni pun is considered solution of the PDE. That's it je benda yang nak bagi tahu. Okay, for example kat sini we have example 2. Example 2, find solutions U of the PDE UXX minus U depending on X and Y. Okay, kat sini nak bagi tahunya X kat sini nampak satu variable je, tapi hakikatnya X kat sini there are variable where it also depends, which is depends on Y. So you have UXX minus U. So UXX ni apa maksud dia? This is second derivative of X. So we have del square U over del X square minus with U equals to 0. So macam mana kita solve ni? Ibarat macam kita solve apa tu ODE sebelum ni lah. Kan ni Y double prime, this one is partial instead of the derivative biasa. This is a partial, so you may change it become R juga, R square minus with 1 equals to 0. We have R equals to plus minus 1. So that's why here we have e to the power of X, B is e power of minus X. But instead of we have C1 and C2 here, because it is mentioned that it depends on variable Y, so we have C1 instead of C1 and C2, because it depends on variable Y, so we have AY e to the power of X plus with BY e to the power of minus X. Okay. Alright, and then here untuk you fahamkan 3 fundamental examples of PDEs ni, saya nak you all have spend some time untuk view this YouTube. Okay, pergi dekat lecture notes, buka tengok through video ni, tak boleh tekan lah link ni. Okay, open the lecture notes and press this link to have untuk fahamkan 3 types of fundamental examples of PDE using for wave equation, Higgs equation and Laplace equation, supaya you boleh faham apa sebenarnya kegunaan PDEs ni, okay, and how does it being formed. Alright, okay, so that's all for the first part of video for today's asynchronous lecture.